Hi guys, welcome back to Tronic Energy, where we do fun stuff all day, all the time. So today we are continuing with our series of making the 8x1 multiplexer, and you can see the connection are continuing to grow slowly by slowly. So we are moving on well. And yes, so today we are going to do the things a little bit differently because last time if you can remember, we finished up on our first multiplexer. All the inputs of our 4x1 multiplexer were full. We had A with the AND gate, B with the OR gate, C with the NAND gate, and D with the NOR gate, meaning that we finished up the first 4x1. And we said that the next video we are going to connect those two multiplexers. There are two multiplexers in this IC. It's a 74153, and the first multiplexer is on the top side and the other one is on the bottom side. So we used the one on the top side and now we want to use the one on the bottom side by connecting the two multiplexers together. So that's why you are seeing three LEDs, but we were only using these two LEDs because for a 4x1 multiplexer the select should only be 2. For 8x1, if you're making an 8x1, the select should be 3 LEDs. So the codes are going to change. They are going to be 3. Like for the AND gate will be 0 0 0, the OR gate will be 0 0 1, the NAND gate will be 0 1 0, the NOR gate will be 0 1 1, and so on and so forth until 7. Yes, so that's what we are going to do in the next couple of videos. We are going to connect it and check. So for today, I want to show you how you can connect these two multiplexers in order to make an 8x1 multiplexer. So today we are not going to do more of demonstration. We are going to do more theory in order for you to understand how these two multiplexers are connected. If you can remember very well how I explained how the output is connected, how the enable is connected to the output, it would be very nice. So if you can remember, I said the enable is connected to an AND gate and also the output to an AND gate, but the enable has an inverted section there to that AND gate. Then the output is taken to the LED or any other thing that you're driving. So for the enable, for you to see the output, the enable has to be 0. So meaning that meaning that the circuit, the enable should be connected to ground at all times for you to see the output of that multiplexer that you want to see the output. So if you feed it 1, it's going to turn off this multiplexer. Yes, but if it's just 0, if you connect it to ground, it's going to show you the output of your multiplexer and which operation that you want to see. So I've created a circuit which I think it's an ideal one that is going to explain very well on how you can connect these two multiplexers to make an 8x1 multiplexer using the enable pins. Okay, so as I said, for an 8x1 multiplexer, it should have 3 selects. Because we had already S0, we had S1, so we need to add another one called S2, and that S2 should be controlling these two enables for you to get the output that you want. So this is the S2 right here, and for the S2 we want to give it 2 states, or it should be having 2 states: when it's on and when it's off. When it's on, let's start when it's off. When it's off, it should enable this first multiplexer and disable this. So when it's off, it does 2 operations. It enables this first multiplexer and disables this second multiplexer. Let's check on how it does that. So when it's off, meaning that it's 0, that 0 enters this first junction. That 0 comes in this section where it gets the collector of this transistor. Nothing really happens because it's 0. That 0 also enters this enable pin and it's turned into 1, meaning that this first multiplexer is enabled. Okay, yes, that 0 on the other side of the junction, it goes straight to this base of this transistor. Once it enters the transistor at the base, then it's going to disable this because there's no current to drive that pin to ground, because this pin requires ground in order to work well, or in order to enable the circuit. So it's going to turn this off. Okay, that 0 also continues moving on and it enters this inverter. Once it enters this inverter, it's going to come in this base. So once it is inverted, it's going to be 1, because it was 0, it's going to be 1. That 1 enters this base of this transistor. Once it enters the base of the transistor, it's going to enable this enable pin to be connected to ground, because there's some current in the base. Okay, that one also comes and enters the collector here. Once it enters the collector, it cannot go to ground because there's no power here. So it has only one way. It goes up and goes to the enable. So what that one enters the enable and is turned to 0, meaning that it disables this totally. So this bottom max circuit or multiplexer circuit is totally disabled. Okay, hope you have understood that. Then the next state is when this S2 is 1. So when S2 is 1, we want it to disable the first multiplexer and to enable the second multiplexer. Let's check on how it does that. So when it's 1, that one enters, that one comes from this junction, goes and comes here. Okay, when it comes here, it goes straight to this enable. When it goes to this enable, it's going to turn this enable to 0 because it's inverted to 0. It's going to disable this because of that 0. It's going to totally disable that AND gate or that enable section. So you cannot see the output, meaning that you have disabled this multiplexer. Okay, that one also comes on the other side of the junction. It comes and enters this BC547 at the base, meaning that it enables this transistor. Okay, so this enable can be connected to ground. Okay, let's move on. That one also enters this after it has moved from the junction, it enters this inverter. Once it enters the inverter, it's going to be turned to 0. Okay, hope I'm not going too fast. So once it enters the inverter, it's going to be turned to 0. That 0 comes and enters this BC547 at the base. Once it enters this BC547 at the base, meaning that current cannot come and go to ground, meaning that this circuit is totally disabled because it has no connection to ground, and at the same time the collector, and at the same time this first, because it's 1 on this before it enters the inverter, it's 1, the 1 cannot pass here because there's no power here, so it's going to just go up and disable this, so meaning that this top circuit is totally disabled. So that 0 at the same time comes here, enters the collector of this transistor. That 0, once it enters the collector of this, it's not going to affect anything. Actually, it's going to enable this because that 0 is going to be inverted to be 1 at this section. Once it is inverted to be 1 and it aligns with this output, meaning that this max circuit will be enabled. Yes, so that's basically how you can connect those two multiplexer circuits and play around with them, because this select should be doing two operations. It should be doing two operations, enabling this, disabling this, at the second time disabling this, enabling this. So yeah, so that's how you can connect the S2. So this S2 will be this last LED. This last LED will be S2. So this first LED was S0, this second one was S1, and the last one will be S2. So this S2 will be doing these operations. That's why you can see I've already connected them. You can see these two transistors, the resistors right there, the inverter. I've used it somewhere. The inverter, this inverter, you can see on the end there. I've used it somewhere, and yes. So these are the connections, and I've already connected the enables in this configuration. So I'm going to do one simple operation. Then next video we are going now to connect. We start connecting these other data lines of this bottom max circuit, and we are going to give this operation different codes according to the 8x1 multiplexer, because already we have connected it. So this for now it's an 8x1 multiplexer. So let's do a simple operation for you to understand what the circuit means. So let me turn this on. It's on. So let's do a simple operation, AND operation. So for AND operation, if you can remember very well, these both inputs have to be on for you to give this an output. So let's turn the A and B on. I've not connected ground. Okay, let's turn this both on like that. So if you can remember very well, the AND operation, both inputs have to be on for you to give an output. And why does it give an output? Because the select are 0 0. So that was the code for AND, if you can remember very well. So what I'm going to do, I'm going to disable this. As I've said here, because it's on, you can see already it's on. Once I turn this S2, it's going to disable the first multiplexer. So this is the first multiplexer, and the first multiplexer has given a 1 output. So for me to disable it, I'm just going to turn this on. When I turn this on, that on is going to come, that one is going to come here. It's going to come here and disable this, because that one will be inverted to 0, meaning that this first AND gate will be 0. This first AND gate will be disabled. So this first multiplexer will be disabled, and at the same time that one comes here and enables this bottom one. Okay, that one also comes here, and this is inverted to 0, and that 0 enters this BC547 and disables this transistor. So this first circuit is disabled. This first max circuit is disabled. Let's check on that. So this is S2, and when I turn it on, I expect this to be off because I've turned the multiplexer side off. So let's turn it on, and immediately you can see that it's off, because we have fed the enable pin of that multiplexer 1, and when you feed it 1, it's going to turn 0. So that's basically how a max circuit operates. And yeah, so thank you very much guys for watching. The couple of next videos we are going to check, we are going to do more. We are going to start connecting these other multiplexer data lines, and yeah, so for now these are 8x1 multiplexer. So stick for more of these, and yeah, hope to see you next time. Goodbye.